Good morning, class. Let's start the topic. Today we are going to do EMF of a cell. EMF of a cell or E cell. Now what is this EMF of a cell? This arises due to the potential difference between the two electrodes. It arises due to potential difference between the two electrodes. Two electrode means the anode and cathode. So if I want to define this, what should I say? Due to difference in potential between the two electrodes, the current will flow from an electrode at higher potential to an electrode at lower potential. Then the EMF generated, it is known as EMF of a cell or the E cell. Okay, and this all, it is for a galvanic cell, right? So E cell, what do we write? E cell we write as oxidation potential of anode. Because at anode oxidation occurs, plus reduction potential of cathode. Reduction potential of cathode. Right, we know what is the setup. Like in anode, oxidation occurs, so anode has excess of electrons, right? So anode is the electrode at lower potential, and cathode has deficiency of electrons, so cathode is the electrode at higher potential. That's why electron flows from anode to cathode and current flows in the opposite direction, that is from cathode to anode, right? And then the potential that we get, that is the EMF of a cell, right? So we know, as per modern convention, oxidation potentials are represented in terms of reduction potentials. So we can write by changing the sign will be opposite. So E anode, this is reduction potential, plus E cathode, this is also your reduction potential. Therefore I can write E cathode minus E anode is always the potential for cathode will be more than the potential for anode, or I can write E right electrode minus E left, because we have done this in the representation that the right compartment represents the cathodic compartment and the left one represents the anodic compartment. So this is basically your EMF of a cell that arises due to the potential difference between the two electrodes. Okay, now we have standard hydrogen electrode. Standard hydrogen electrode. Standard hydrogen electrode, that is SHE. Now what is standard hydrogen electrode? When hydrogen gas at 1 bar pressure is adsorbed on platinum surface or platinum foil and comes in contact with H plus ion of 1 molar concentration at 298 Kelvin. This setup is known as your standard hydrogen electrode. Okay, now standard hydrogen electrode can act as cathode, it can also act as anode. So it is also known as reversible electrode. It is known as reversible electrode. Now when it acts as anode, what happens? When it acts as anode, oxidation will occur. So this will be my reaction. Okay, this is reaction at anode. I mean when SHE acts as anode, and when it acts as cathode, then obviously reduction will be happening. Sorry, this one will be, sorry. When it acts as anode, it will be like this. And when it acts as cathode, the opposite reaction, that is 2H positive plus 2E will give you H2. Right? So anode oxidation occurs, cathode reduction occurs. Okay? So this is basically the nature of the standard hydrogen electrode. It is a reversible electrode. Now next one we have single electrode potential. Single electrode potential means single electrode potential. Now what is it? In order to find the electrode potential values for a given electrode, it is coupled with standard hydrogen electrode. Basically, standard hydrogen electrode, it acts as the reference electrode. Why reference electrode? Because it can act as both cathode and anode. Okay, and its potential value is 0 volt. Right, so it is basically used as a reference electrode and is coupled with a given electrode whose potential value I want to calculate. That is basically your single electrode potential. Now what happened? This single electrode potential term got modified to a more appropriate term that was known as your standard reduction potential. Standard reduction potential. Now why standard word we are using? Because here one electrode is coupled with standard hydrogen electrode. So hydrogen electrode is standard, there is H2 gas at 1 bar pressure, then H plus ion 1 molar concentration. So the given electrode components need to also have everything in their standard states. Right, so the single electrode potential term got modified to standard electrode potential. So what is the meaning of standard electrode potential? It means that components for the given half cell, to be in their standard states. Now standard states means temperature your 298 Kelvin, pressure will be 1 bar if it involves gaseous component, and ionic concentration will be 1 molar. That is your single electrode potential got modified to this term. Okay, but the meaning is same and it is represented as E naught. Okay. Now significance of signs of E naught. What is the significance of this sign of standard electrode potential? Okay. If E naught or E0 is positive, then the given electrode that is coupled with standard hydrogen electrode, that will be acting as cathode. The given electrode acts as cathode. That means SHE acts as anode if E0 value of the given electrode is positive. If E0 value is negative, then what happens? That electrode will be acting as anode and hydrogen electrode will be acting as cathode for a spontaneous reaction. When positive, the given electrode acts as cathode and SHE acts as anode, and when negative, the given electrode acts as anode and SHE acts as cathode for a spontaneous reaction. Right? This is basically your significance of E0. And when I am talking about standard electrode potential, this is basically your standard reduction potential. Okay, whatever potential we are going to speak, they will be reduction potential only, not oxidation potentials. Now, what are the drawbacks of SHE? The first drawback is that it is difficult to maintain hydrogen gas at 1 bar pressure for a long period of time. Then we are using there a platinum foil because hydrogen gas gets absorbed on it. So platinum foil gets readily poisoned. So it is difficult to keep platinum foil for a long time poison free. And the last one, it is difficult to maintain H plus ion concentration at 1 molar. Okay, so these are the few limitations. So we use a secondary reference electrode that is known as saturated calomel electrode. This is a secondary reference electrode that we can use, and usually this is only used in the labs because its electrode potential value remains constant for a long period of time. It doesn't change. So we can use this as a secondary reference electrode other than SHE. Okay. Now we have standard EMF of a cell. Standard EMF of a cell means this one, E0 cell. What is the standard EMF means? How can we define it? Standard EMF of a cell, it represents that all the components for a given cell reaction, or all the components in the half cells, they have to be in their standard states. That means if it involves ions, 1 molar concentration, if it has gas, 1 bar pressure, and temperature has to be 298 Kelvin. Right, so that represents your standard EMF of a given cell. Now, E0 cell, how do we write? We know already E cell formula. E cell formula is what? E cathode minus E anode. So obviously E0 cell will be the same thing, except we have to put not sign. So E0 cathode minus E0 anode, or your E0 right electrode minus E0 left electrode. This is what basically E0 cell represents. Now what is the indication of the sign of E0 cell? If E0 cell is positive, my reaction is spontaneous. My reaction is spontaneous means your chemical energy will be getting converted to electrical energy. That is, current will be generated. Okay. But if this E0 cell is negative, it will be non-spontaneous. Non-spontaneous means your chemical energy will not be getting converted to electrical energy. That is the meaning of non-spontaneous reaction. Okay, so these are the indication of the significance of the signs of E0 of a cell. right? Now when I'm talking about galvanic cell, now this galvanic cell, after some time it stops working. Now why is it so? Because in galvanic cell, at the oxidation half cell, oxidation occurs, and reduction half cell, reduction occurs. So what happens? The concentration of ions in the oxidation half cell will be increasing. So reduction potential of anode will increase, because reduction potential is directly proportional to the concentration of the ions. If the concentration of the ion increases, reduction potential will also increase. Now if we come to your reduction half cell, what will happen? The concentration of ions decreases because they undergo the process of reduction. So decreases. As a result, the reduction potential of cathode will also decrease. Cathode decrease. Now a situation will come when the reduction potential of both anode and cathode will become equal, and at that point your E cell will be equals to 0. Then the cell will stop working. That means when the potential of cathode and anode gets equal, E cell or EMF is equals to 0, so the cell stops working. Let's see the plot. If I talk about the graphical plot, this is reduction potential. This is your time. This is time. Right. Now what happens? Reduction potential of cathode decreases. Reduction potential of anode increases. So at this particular point, at a particular point here, E anode equals to E cathode. So E cell will be equals to 0. So cell stops working. Okay, and this one, this down, this will represent cathode because its potential decreases, and this represents anode because potential increases. So slowly what do we see? The potential, that is EMF, slowly decreases, because EMF is what? The difference between the potentials of cathode and anode. So first the difference was this much, huge difference. So slowly the difference, that is EMF, is decreasing, and then at a point it is getting equals to 0 when the cell stops working. So this is what the reason that the cell stops working after some time. Okay, because E cell comes, this E cell gets equals to 0. So that's it, class 12. Thank you.